Hi guys, my name is Kaushik and my friend Ramcharan. We are currently in studying data science, masters of professional studies in data science, and this is our final project presentation. That's a capstone project presentation. The title of our project is synthetic phase generation using the GAN methods. We are doing this under the guidance of our professor Chao Ji Wang, and here we go. I'll firstly start with the introduction of our project. So, as the name suggests, synthetic phase generation usually refers to artificially generated phases using machine learning data models, which have a wide range of practical applications in today's era. Using high computational power and advanced technologies, it has become possible to achieve complex tasks using the generative networks. Our project 2 uses this model to generate the trained images to be useful for real-time applications. Why exactly do we need these synthetically generated faces is the question that arises. So simply stating, to create more data and to be used in research and development tasks, it might sound like it might not be a big deal, but a lot of our Instagram, the Twitter usage we actually use in everyday lives are based on these research and developmental projects. Some of these, I would like to just give some of the examples which are generated using this GAN model, such as creating gaming characters, Instagram influencers, the wide range of promotions that we see on Instagram, Twitter, Facebook, and elsewhere usually use these methods, uh, going by privacy and security by the government agencies, airport security screenings, fake imposter detections, and very much more. So, the technology behind our project is GAN, which is short for Generative Adversarial Networks, and many firms and R&Ds started working on these GANs extensively in recent days. So, in data science, it's very common to face these issues like data set is not big enough, data set is not diverse enough, the amount of data present for one label dominates the amount of data present for another. We personally faced this issue while creating a model for attendance system by face recognition in our previous semester. And face synthesis can be used as data augmentation technique in cases to create more data. Just for example, it's like Microsoft created a complete data set with synthetic faces. When tested on different models, the performance was much better than models trained using normal data set on the test data. So Microsoft says this is because of the diversity added in the data set, similar to what we are doing in our current project. So content creators can use this technique whenever they want images of so many people, like in cases of metaverse, or when they have to use a face for some sensitive issue that could be uncomfortable for the person whose face is being displayed. So this technique can also be used to create avatars. So, so what is the objective of our project? So like as already discussed, it's to create a data model. To be specific, like we already mentioned that it's going to be GAN machine learning technology, so which can synthesize images of faces, which are generated randomly on basis of different facial features. So coming to the importance of this face recognition system. We are using a wide range of facial features, which some of these features could be the nose of a person, his hair or her hair, the lips of a person, baldness, eyes, mustache, beard, the shape of their faces, or a smile, and so much more. So just to for our comfortability, we have used like 38 unique features and attributes for our project. So in brief, I would like to just go down through some of the tasks that we performed. So the first thing is we loaded the data set from a Chinese website. It's from the University of Hong Kong. And the second thing is we have done pre-processing for the images and fixed the resolution of each image. And then we created a data model and trained it with the data set of images we have. Then we trained a discriminator to know if an image is real or generated. Then we created new images using the generator, and we finally represented the generated images using a UI that we generated using the front end and back end UI generation methods. So we had certain questions in mind when we started working on the GAN model. So some of which include like what can be the key performance indicators of the model? Can we give input parameters to the model so that we can get a particular type of face? Will the generated faces be completely human distinguishable, or will there be any similarity among already generated images? Are these faces generated usable in other data models? Also, like, can we include specific features like smile and beard into the models and then train it again? So we can see that the success stories of this face generation method. Just for example, there is this Instagram influencer named Michaela Souza who got 1 million followers. Uh, it was announced that she wasn't real, not until later in the period. It seemed like an indisputable fact that she wasn't real, as reported from the cut detected. It's also been like found out as the coolest idea in the past 20 years. So the data that we gathered to use in this project is basically obtained from the Chinese University of Hong Kong, as I already mentioned. So it actually contains some 200,000 face images, which can be used in any other project. So I would just like to go over our data model, that is a machine learning data model, in brief. Um, so it's called the GAN model, the Generative Adversarial Network. It's a type of neural network architecture for generative modeling. Basically means using a model to generate new examples that possibly come from existing sample of images, such as human faces that we used in our project. It's a network of two neural network models. One is called the generator or a generator network, as you can see in the diagram, and the other is called the discriminator or the discriminative network. So how these two networks work with images will be discussed by my friend in some time. So some of the very important applications that the GANs include forming image datasets for random research purposes, generating realistic photographs, text image translation, which is very popular, image to image translation, photo bonding, 3D object generation, etc. So these are some of the most important and demanding working applications of the generative adversarial networks. Now my friend Ramcharan will take over.
Hi guys, my name is Ramcharan, the other teammate for this project. So let's go into the generative adversarial network model. So basically, generative adversarial network models belong to the field of unsupervised learning, which aims to study algorithms that learn underlying structure of given data without specifying the target value. So here the generator adversarial network has major focus on images, as well as it has many use cases in wider applications, as my friend Kaushik discussed before. So basically it has two deep networks. One is generator and one is discriminator. The generator takes input and generates image as an output, whereas the discriminator takes image as an input and gives true or false as an output. Here true means it is a real image and false means it is a synthetic image. Both the generator and discriminator are two-dimensional convolution neural networks. So here is the generator model architecture. You can see these are the things we have developed from our code. We have developed a dense layer, ReLU, and reshaped the model and using the two-dimensional sampling as well as the convolution two-dimensional sampling, and as well as we have done batch normalization, and this is the generator architecture model output. And so when it comes to generator model, let's learn more about it. So here we are using some noise, let's assume that as Z as an input to the generator, which we can assume as G. To create as an image, let's assume that as X, which means X equals to Z of Z. So here let's dive into more about this generator. So the main aim of the generator is we need to learn how to create the data in such a way that the discriminator is not able to distinguish whether it's an real or fake. So the competition between these two is what improves their knowledge quality of image generation. So what we have done is the generator takes few inputs as we discussed before and acts similar to a decoder to generate the image. So first we start with the one dimension dense layer, and then we slowly increase the size of the dense layer, and then probably we reshape the dense layer to 2D convolution, and then apply smaller convolutions, and then apply bigger convolutions finally to achieve an image of size we expected. You can take the look of model architecture discriminator. Like these are things we have generated similar to the generator. So we have generated convolution two-dimensional and ReLU, and we have added this convolution two-dimensional, and we have done batch normalization to that. So let's dive into what discriminator means. So the discriminator starts with taking an image as input, and then layers follow like normal image classification layers. We apply convolutions to get the resultant output size smaller and smaller. We increase the number of kernels slowly, and then we finally flatten all the neurons. And then we apply dense layers until we get the output neuron. This is basically about the discriminator. So in the background, what discriminator assumes is like by training with real images and generated images, generative adversarial network model builds a discriminator to learn what features make images real. Then this discriminator will provide feedback to the generator to create better accuracy images. Basically, the discriminator looks at real images which are trained as well as the generated images separately, and then it distinguishes whether the input images is real or generated. So when it comes to training, for training the generator, we are giving external noise as input as we discussed before to the generator. As the generator creates some images, which is used to train the discriminator. Actually, here we provide the discriminator with some features or images for it to learn and to train. Next, we train the generator, and then we take the batch of images that is created and put them to discriminator again. By this process, by continuously doing this process, the generator tricks the discriminator into outputting false positives. This is basically what we have done in this project. And the tech stack, when it comes to the tech stack, we have used Python language to code our project, and as well as we have used Google Collaboratory as IDE, and we have used Keras, OpenCV, TensorFlow, NumPy, and Scikit-learn as the modules for this project. And as you can see, these are the faces we have generated by using this generative adversarial network model. Uh, you can observe these faces. As you can feel that you can assume that these can be generated synthetically. So the problems we have faced while doing this project is the generator and discriminator models were not big enough. However, as you can see, the images that came out of these models were not so good enough. It can be found that these images can be synthetic. So the reason might be the models could not reach to the limited resources we have. Uh, One of these reasons is that the models required repetitive batch training on these images. Once training is done, these images itself is heavily resource consuming. And also the training we have done many times required a lot of time, which never allowed the model to converge fully. The solution we expected for the better outcomes are the convergence can be achieved by doing following things. One is to provide more computing resources, and also using these better GPUs we can achieve much better images, and also by using higher random access memory and more computational time. The future work what we expected is as more hardware is available now times, more epochs can be performed to better convergence, and we can achieve better quality of these images, and also more type of images could be added to get more diverse faces, and model could be more generalized to produce not just images but also other things like handwritten digits, anime images, etc. using this transfer learning. Model can be modified to give facial features as input, and the resultant face contains those features. Thank you.